Assalamualaikum and very good morning. So today we continue our lecture with topic 5, which is chemical bonding. So for today, this is the outline of the topic 5. So after going through this topic, students should be able to draw the Lewis dot symbol for compounds and identify the bond that exist in the compounds and identify the bonds that exist between molecules in compounds, and finally predict the molecular geometry by using the Vesper model. So for today, I will go through learning objective number 1 and 2 first. So what is the valence electron? Valence electrons are the outer shell electrons of an atom. So the valence electron are the electrons that participate in chemical bonding. For example, if you have a group 1 here, group 1, so the configuration should be an S1. So the valence electron for the group 1 is 1. Whereas for group 7, which is referring to halogen group, so the configuration is NS2 and P5. And the valence electron is 7 here, 5 and 2. So, chemical symbol of the element surrounded by a number of dots which represent the atom's valence electron. This is the definition for Lewis dot symbols, and it is a way of showing valence electrons of atoms. For the main group element, the A group numbers give the number of valence electron, and then place 1 dot per valence electron on each of the 4 sides of the element symbol. So pair the dots until all the valence electrons are used. Okay, please take a look at group 5, which is referring to nitrogen. So the valence electron for nitrogen is 5. So when you draw the configuration here, so it will be 1s2, 2s2, 2p3. So 3 and 2 is the valence electron for nitrogen. So how to draw Lewis dot symbol for electron valence for nitrogen? So place 1 dot for valence on each of the 4 sides. So 1, 2, 3, 4. And the rest of that 1 you should put here. Okay. So Lewis electron dot symbol for element in period 2 and 3. This is period 2 and period 3. So for period 2, so you need to arrange the electron valence like this. 2, 3, 4, 5, and here is 6, 7, and 8. 2, 4, 6, 8. And here is the period 3. What is a chemical bonding? Joining 2 or more atoms involving redistribution of electron either by transfer or sharing of electron between themselves. So to produce a chemical bonding, 2 or more atoms will transfer or share between each other. And a chemical bond is a force which holds 2 or more atoms, ion, molecules, or any combination of these together. And there are 3 types of chemical bonding, which are ionic bonding, representing the bonding between metal with non-metal, and covalent bonding, or covalent bond, representing non-metal with a non-metal, and metallic bond representing the bonding between metal with metal. And this is the three types of chemical bonding. So here is ionic bonding. Ionic bonding normally can be observed in salt, or the name for salt is sodium chloride. Because sodium is more electropositive, here chlorine is more electronegative. The electronegativity between the value here is 2 positive, here is 2 negative. When here it can produce, we call as ionic bonding, because here is sodium is categorized as electrophile because it electrophile, so it will accept electron from not accept. So here sodium and Cl. So sodium, it will give one valence electron to the chlorine. So after that, sodium will be more positive because it gives one electron to chlorine. So it will form ionic bonding. So how about Cl and Br? Cl and Br we call as a covalent bonding. Involve the electron sharing, because the electronegativity between the Cl and Br is almost same. It's because it is in group 7, so the electronegativity is not very different to each other. So normally it will exhibit covalent bonding. And for metallic bonding, so here is sodium and here is electron pool, and here we call as electron C. Means that the electron bonding exists between metal and metal. Exists between sodium atom with the sodium atom to form metallic bonding. And for the ionic bonding or ionic bond, transfer of electron from metal atoms to non-metal atoms to form ions that come together in a solid ionic compound. So in this case, we have sodium atom. So it will donate this electron valence here because it has one electron valence at n equal to 3. So here it donate is what? It's one electron valence. When it donates, it become electropositive. Means that it lost one of the electron here. Okay, after that, this electron then enter the non-metal, causing it to form a negatively charged anion which also has a stable electron configuration. So here, this Cl will accept this electron, and when this Cl accept this electron, it will become electronegative. Here, at the beginning of the reaction, the configuration is 3p5, and when it accept one electron, it will become 3p6. And for the ionic bonding, the electrostatic force holds ion together in ionic compound is called ionic bond. And the arrangement of this ion is known as ion lattice structure. Okay, there are three ways to represent the formation of ion lithium and ion fluorine ion through electron transfer. Okay, this is the configuration, electron configuration for lithium. And this is the electron configuration for fluorine. So, lithium will donate its electron to the fluorine. So, here will become P6. And here will gone. Because it already donate to fluorine. And here will become P6. And for orbital diagram, so you can draw like this. Plus, like this. And here is 1s2 and here is 1s2, 2s2, 2p6. In Lewis electron dot symbol, you only need to show the electron valence for lithium and fluorine. 2, 4, 6, 7. So the electron valence for fluorine is 7 at n equal to 2. N equal to 2 is the outside. Petala yang paling luar. So, it consists of 7 electron valence. So, it accepts once electron valence from lithium. So, lithium will be positive charge. And at the same time, fluorine accept 1 electron from lithium. It will become negative charge. So, exercise, use orbital diagram and Lewis symbol to show the formation of Na plus and O2 minus ion from the atom. So, if orbital diagram, you need to present your answer in the form of this diagram, and Lewis symbol, you need to present like this. So, for sodium, here is 1. React for oxygen atom in neutral state. The petala paling luar ni adalah 2, 4, 6, 6. And then, so what happened here is O2, it accept 2. Here is use formation of sodium. So sodium, you have two atom sodium. So 2 atom sodium. So here you give 1 electron to oxygen and another 1 electron to oxygen. Okay. So it will become 2, 4, 6, 8. So because here 2 electron added here because it accept from 1 sodium and another 1 sodium. So 1 electron donate to oxygen, 1 electron donate to oxygen. So oxygen will become 2, 4, 6, 8. So it will become octet. And here is 2 and A plus means that there are 2 sodium ion in the reaction. And what is a covalent bond? Covalent bond is atom in a molecule share electron and are held together by electrostatic attraction between the shared electron and the nuclei of the atoms involved, and usually form between a non-metallic elements. The bond is the force of attraction between the pair of shared electrons. So, if you have a hydrogen molecule form when the hydrogen atom share with its 1 electron valence with another hydrogen atom. So here it will form covalent bonding. So attraction between oppositely charged nuclei and shared electron will cause electrostatic in nature. The shared electron pairs spend most of the time between the 2 nuclei. And there are 5 types of covalent bond, which are single bond, double bond, triple bond, covalent bond in negative ion, and coordinative bond, or we call as dative bond. Okay, what is a single bond? Single bond or two atoms are held together by one electron pair. So has a bond order of 1. For example, HF, H2, F2 or Cl2. So chlorine atom, if you have one chlorine atom combine with another chlorine atom, so it will share for both, then it will become octet. So the sharing produce single bond, which is representing covalent bond. And how about double bond? Double bond consists of two bonding electron pair, because we have one pair electron pair, another one electron pair. Here one pair, two pair. So you will form double bond. Okay. And for the triple bond consists of three bonding pair. For example, in N2. So one pair, two pair, and three pair. 2, 4, 6, 8. So should be in Lewis dot structure, the electron valence should be in octet. Octet means that the number of electron valence should be 8. And for covalent bond in negative ion, for example, carbonate ion. So electron charge form negative charge. Here is electron charge form negative charge, and the dot, white dot, electron from oxygen, and X dot is electron from carbon. And what is dative bond? Bond in which two atoms share a pair of electrons, both the electron being donated by one atom. The process of forming a dative bond is called coordination. Electron pair donor, atom which donates the lone pair. Atom must have at least one pair unshared electron. And electron pair acceptor yang menerima, atom which accept the pair of electron and must have at least one vacant. For example, here you have NH3 react with H plus, so it will form ammonium ion. What is a bond polarity? So, whenever atoms of different electronegativity form a bond, the bonding pair is shared equally. The unequal sharing of electron leads to a partial electrical charges because hydrogen is more electropositive while chlorine is more electronegative. So, when the difference between the electronegativity is increased, so the polarity also increase. Such a polar covalent bond can be depicted by a polar arrow pointing towards the negative pole. Or here we call as delta positive, here we call as delta negative. Delta positive represent hydrogen atom which is more electropositive compared to chlorine, which exhibit more electronegative behavior. And when you draw the arrow, this arrow should be pointing towards the negative pole. And here is electron-rich region and here is electron-poor region. So the electronegativity of common element. So here should be region of electropositive. Here is a region normally at halogen group, electronegative. So here the electronegativity increase when we across the period from left to right. If we in the group, if we start from bottom to up in the same group, the electronegativity will increase. And the variation of electronegativity with atomic number. So electronegativity is quite different to each species of compound. And to know the bond polarity, what is a bond polarity? Bond polarity is electronegativity difference ranges for classifying ionic character of chemical bond. Because electronegativity value or electronegativity difference, from this value we can know is it the molecule will exhibit either ionic bonding, covalent bonding, polar covalent bonding or non-polar covalent bonding. So if you calculate the value is equal to 0, the electronegativity difference is equal to 0. So it is referring to non-polar covalent bonding. And when the value of electronegativity less than 2, so it exhibit 2 less than 2. So it is referring to polar covalent bond. And finally, if the value of electronegativity difference is more than 2, it's exhibit ionic bonding and increasing difference in electronegativity. So for the covalent bonding, we share the electron. For the polar covalent, partial transfer of electron, and ionic bonding is transfer of electron. Classify the following bond as ionic, polar, covalent or covalent. The bond in cesium chloride, the bond in the hydrogen sulfide and the nitride bond and NH2. Cesium is 0.7, Cl is 3. So 3 minus 0.7, you get 2.3. So the value is more than 2. So ionic. When the hydrogen is 2.1, the S is 2.5, value is 0.4, so no polar covalent. When the nitrogen is 3, she is 0, so non-polar covalent. Okay, what is a metallic bond? Metallic bonding only occurs between the metals. Metallic bonding is the electrostatic force of attraction between the delocalized sea of electron and the positive ion which are arranged in a regular lattice. And properties of metal accounted by metallic bond are metallic luster, malleable, which it can be hammered into thin sheet, and ductile, can be pulled into wires, good conductors of heat and electricity, and high boiling point. In the solid state, metal atoms are packed so close with each other, and the valence electron become attracted to the positively charged nuclei for several neighbors and become free from attractive force of its nucleus. This free electron delocalized over the solid result in a closely packed positive ion embedded in a sea of delocalized valence electron. And basically here we call as electron sea or electron cloud. So electron from all the metals atom from a sea of electrons, sea of delocalized electron that can flow around this metal cation. Okay, give the correct type of bonding for following. So chromium is metallic. So Cl and F is covalent bond. Nitrogen and oxygen, the electronegativity difference is quite small, so covalent. Magnesium and Cl, magnesium is transition metal, and here is halogen group. should be it is ionic bonding because the electronegativity difference between the magnesium and Cl is quite big, and also here is NiH2O is called as dative covalent bond. So what is octet rule? Octet rule is a simple chemical rule of thumb that states that atoms tend to combine in such a way that they each have 8 in their valence shell. An atom gain, lose, or share electron until they obtain 8 valence electron. The same number of valence electron as the noble gas closest to them is the periodic table. An octet of electron consists of full S and P subshell in an atom, or 2 for hydrogen. When atoms form covalent bond, they tend to share sufficient electron so as to achieve outer shell having 8 electrons. And it indicates how all atoms in molecule are attached to one another and account for all valence electron in all atoms in molecule. And then please take a look of some example for noble gas. So for noble gas, normally for halogen and neon, it has 8 electron valence. So the full octet is NS2 and P6 stable monoatomic gases and don't form compounds. And the octet rule works well with group 1 and 2A metals, aluminium, non-metals, and hydrogen and helium cannot obey because limited to 2 electrons in the N equal to 1 shell, and doesn't work with transition metals and post-transition metal. And how to draw the Lewis structure? We have electron bookkeeping method, way to keep track of electrons. Write chemical symbols surrounded by dots for each electron. So you have group 1, group 2, group 3 and group 4. So the valence electron for all group is 1, 2, 3, 4. So for electron configuration, it will be NS1, NS2, NS1 and P1, NS2 and P2. So this is in Lewis dot structure, helium, hydrogen, helium, lithium, beryllium, sodium, magnesium, boron, carbon, aluminium and silicon. Okay, and this is for group 5, 6, 7 and 8. This is a noble glass group. So diatomic gases, for example, hydrogen and halogen group. Hydrogen with hydrogen, it only has 1 electron. When it share, it becomes 2 electron. Can write share pair of electron as line, or one line we call as a single covalent bond. So what is a diatomic gases? Diatomic gases, we have 1 sharing, 1 pair sharing. So it become diatomic gases. For example, Cl2, Br2 and I2. And same for HCl and HBr, HI, molecule are diatomic of atom that need only 1 electron to complete the octet. How? Because this hydrogen donate its electron to the fluorine. So it will produce here is ionic bonding because here electropositive, here is 2 electronegative. Should be the value is more than 1. And to draw the Lewis structure, we have for non-metal, we have carbon, nitrogen, and oxygen. So carbon should need 4 electrons to form 4 bonds, while nitrogen needs 3 electrons, while oxygen needs 2 electrons to form 2 bonds. So should be in nitrogen, nitrogen should has 1 lone pair, whereas for oxygen should has 2 lone pair. So one single bond produced by sharing 1 pair of electrons between 2 atoms, while many molecules share more than 1 pair of electrons between 2 atoms, and we call as a multiple bond. So how about double bond? Double bond, two atoms share with two pair of electrons here to produce CO2, while for triple bond, it share three pair of electrons. And not all molecules obey the octet rules. Hold rigorously for second row elements like carbon, nitrogen, oxygen, and fluorine. Boron and beryllium sometimes have less than octet. And second row can never have more than 8 electrons, and third row and below of atom often exceed octet. Why? Because n equal to 3 shell can have up to 18 electrons as now have d orbital in valence shell. Okay, this is the method of drawing Lewis structure. Okay, first decide how atoms are bonded. So you need to draw the skeletal structure, arrangement of atom. And for central atom, usually given first and usually least electronegative. And after that, you need to count all valence electron for all atoms and place 2 electrons between each pair of atom. After that, you need to draw the single bond. Then complete of terminal atom attached to the central atom by adding electron in pairs. Place any remaining electron on central atom in pairs. If central atom does not have octet, form double bonds. If necessary, form triple bond. Okay, for example, you have Si. This is the skeletal structure for SiF4. So 1 Si. 1 Si, you have 1 times 4 electron. 4 electron is the electron valence for Si. So you have 4. So fluorine, you have 4 fluorine times 7. 7 is electron valence for fluorine. So you have 28. 28 plus 4, you get 32. So you have here single bond. Okay, single bond. Why we minus 8? Because here is 2, 4, 6, 8. 2 electron that shared by fluorine and silicon. So minus 8. So you get 24. 24. You need to minus back with F. Lone pair for F lone pair minus 24. So you get 0. And then you need to complete terminal atom for octet. So carbonate CO3 to minus oxo and ion. So carbon will be the central because carbon is almost neutral. And oxygen will be the terminal atom around the carbon. And the hydrogen will attach to 2O. Okay, like this. This is the skeletal structure for H2CO3. And 1 carbon times 4 electron valence, you get 4. So 3 times 6, you get 18. And 2 times 1, you get 2. So total up is 24. So single bond is 2, 4, 6, 8, 10. So you get 14. 14 minus, is it oxygen has a lone pair or not? No. Minus 14, you get 0. So too few electron. So must convert one of the lone pair on oxygen to second bond to carbon. So one lone pair here will donate here to form another single bond. And at the end of the reaction, it produce double bond between carbon and oxygen. And for N2 and F2, so should be F2 is outside. So at the central is nitrogen because nitrogen is almost neutral, is quite neutral compared to fluorine is more electronegative. So 2 times 5 you get 10, 2 times 7 you get 14, then you get 24. So here how many electron here? 2, 4, 6. You get 18. 18 minus 12. How you get 12? So you get 2, 4, 6, 8, 9, 10, 11. No, this is the F lone pair. 2, 4, 6. 2, 4, 6. So 12. Only fluorine lone pair. So you get 6. Nitrogen electron is 2, 2, 4, 6. So nitrogen electron is 6. So you get here is 0. Ni betul ke tak ni? Macam tak betul kan? So not enough electron to complete the octet on nitrogen. So here must form the double bond to satisfy both octet. So it should form double bond here. Okay. That's it for today.